Now, the title of this panel has to do with what we just heard at with the keynote speech: information, statistics, and geography of available water in the country. You will see in the four presentations an interest paradox. You will see that there is an important amount of information, a great deal of information, but each one of the speakers will mention that the amount of information that is still lacking or would be necessary to understand the process is humongous. At the previous conference, it was said that previously we had more information. Maybe we didn't have more information, but what is a reality is that we have more demand for information. The amount of information we have is not enough to answer all the questions. Previously, the models to simulate the flows in the basins, we had the necessary information, but now we have so much information that this flow cannot be determined. There are many paradoxes in terms of the amount and quality of information available. Maybe 15 years ago, we were not concerned if the measurements were not correct in the slant of the land, but the model was sufficiently general to make it work. But now we have faults in the quality of the information, so we obtain complicated results. So we need information on quality needs, a topic which is a topic that will be analyzed through the debate in this head table. So here I have the pleasure of sharing with us this panel with the following speakers. Raúl Chávez from INEGI. He is one of the experts in regard to economic basins from INEGI. Maybe one of the most undervalued topics, but one of the most desirable in terms of assigning some cost and direct function of what it's worth, and the budget of economic basins. Then we have Elena Kotler from the INE in functionality of basins and the need to have integral approach on the information in order to have an integral management. Ricardo Pisuto from CONAGUA, National Commission for Water, in charge of the difficult task of integrating statistics and geographic information on water. And please believe me, he can tell you how complicated it is to obtain information and compile and review information on water, especially with all the demands from outside that we already heard about in the previous presentations. And then Raúl Chávez from INEGI. No, Raúl Figueroa, who's carrying out important work on the hydrographic network and water accountability. But it's important information on the flows of water inside the basins. Without further ado, we will listen to Raúl Chávez from INEGI, and very quickly I will give you information on him. He's a geographer, specialized in natural resources with some diplomas, has worked in matters related to charts and space aspects from 1993 to 98. He was coordinator of INEGI in the state of Sinaloa. Sinaloa has been working and is the the joint director of interspatial geographical studies. He has worked on the modulation or use of geospatial information and the moderation of flows in the basins. I leave to the consideration of each one of the speakers if he wants to be very formal and talk from the atrium, or he can remain seated at the head table. Thank you very much. Thank you so much. I'm grateful to the university that has given me the privilege of sitting here with you at this panel. What we are going to show right now is the progress carried out within the tasks of the Institute and along the lines of the water topic. It's one more of the important topics that have come up as an important challenge to the Institute since the integration of geospatial information embraces not only one topic but all the infrastructure of spatial data, which is considered for Mexico within the law of statistics and geography in Mexico. So we will start with a hydrographic network. And from this, what we will examine is, in principle, what is the law of the national system of the information, statistics, and geographic system. And there is a series of articles defined by law where we mention that it is important to supply information to society and the state, information of quality, pertinent, and timely, truthful. We have an organization through the National System for Information on Statistics and Geography, which is a consortium for communication, which is established between all the units of the state, that is made up through a series of committees established by law. The information that we look for in statistics and the promotion or the betterment of knowledge also takes in the conservation of this information. Once we have defined it as important information, and that is inscribed in this system as information of national interest. And this represents an important challenge. We have to formulate a series of documents and provide provided with a scientific nature. So it is inscribed as information of national interest. Added to this, we include everything that has to do with the information on geography and the environment within a framework as a subsystem of geographic information. And aside from this, we have a series of articles which frame up the type of information that is classified through this subsystem, as we see the specific case of Article 26 that refers to infrastructure of spatial data and hence natural resources. In regard to Article 27, it describes the state and trends of the environment, and Article 28 to carry out with the units of the state an inventory on natural resources. Well, the next item is the topic itself, the hydrographic network. And so when we start analyzing these types of studies, why should we establish a hydrographic network? All technicians ask themselves this question, and we have the maps at a 50,000 scale. We have sufficient information, but under the scheme of data spatial infrastructure, this takes us to see that everything that has information, when we can establish networks, will have added value due to the fact that it can be used for different purposes. Under this concept, the hydrographic network has become a challenge because we stem from information that was in paper, then we had to digitalize it, and from there we added a series of inputs. Of course, the importance, as you can see, there's a series of studies that have to do with the quality processes of pollution of water that can help to provide information where the flows of water are headed to, the putting together of all the hydrological information. So the network only shows the physical structure of the drainage that can exist, but we don't have the data that within the spatial information framework includes all the information with the characteristics of these networks. So this is part of what we have to integrate, the analysis of system of water, supervision of bases, and the production of charts, maps. And as part of our background, we stem from the information of the 70s, 80s, and 90s, where we have information of basic cartography only in paper, and later on we started following the digitalization processes until we reached the new technological advances to produce hydrographic networks and stem from satellite images like the input referred to by the previous speaker, Dr. Gonzalez. On the other hand, in regard to the background of hydrographic network, in 2005, we carried out work together with the National Water Commission in order to work on the network at a scale of 1 to 250,000. And here we form meteorological documents, and later on these were used to start working on the hydrographic network at a scale of 1 to 50,000. And to put this together, we had a series of inputs for this analysis of addition and connectivity, vectorial information. You can see here currents of water, bodies of water, water sources, channels, other information associated to natural resources. This together with data at a scale of 1 to 250,000, and whenever timely and convenient to have information at a scale of 1 to 50,000. Vectorial information from orthophotography, ortho images, even models in 3 dimensions in order to establish the flows of water in case that through photo interpretation we might have some problems. Additionally, in the transition of the data of origin, we can see an image where we can observe what we have to do, where we have the bodies of water, start making the connections to identify a line, an imaginary line that might give continuity to the flows and the network itself. On the other hand, the components, as we see, in the lines, along the lines, we have more than 6 million lines we could follow in regard to information, 6 million plus, and points of drainage and polygons in the basins. We stem from the sub-basins provided by the National Commission of Water. Classification of lines according to the hydromorphometric indexes in the classification, the simplest classification, and based on this, the representation. We can see this on the slide. The image is not classified on hierarchical levels, and we have a certain order of magnitude. Added to this, as we already mentioned, the units of work had to stem from the limits we established and the different hydrographic networks and the 37 hydrologic regions to adapt them to a scale of 1 to 50,000. And as to characteristics, there's a list which is quite broad, but it is not as broad as we would like it to be, as is the case shown during the keynote address. A great deal of the information we can see is information on which we already have data through lines of flow, drainage, polygons in the sub-basins. And based on this type of information, we have been producing other products mentioned here together with the activities of the Institute. We have some areas on which we have worked with cartography at a scale of 1 to 20,000 in a series of approximately 14,000 making it up. We have 2,500 to start out, and it's been in the areas of the plains along the coastline of the Gulf, in the areas where we suffer floods, and it's a process with digital models of elevation and with a leader system. From this information, what we have been working on is not only the data, the lines, the networks, but also we have tried to create a system based on the models of the runoffs. Here we refer to some elements, simulation methods. We start from studying the volume of water, the runoffs, the flow, profiles of elevation, where the water is headed to, how many inhabitants in the path of water, planimetric visualization and altimetric visualization in 3 dimensions. We have included at meetings we held with the Meteorological National Service. They recommended to include data and get NOAA data as an element that is not only decorative, but it shows how the phenomena come up. And data on climate from climatological stations, we know there are few, as we have said, as we have already heard. There's no maintenance provided to these climate stations. Many have been lost, and it's part of what we are considering. It's all the elements of altimetry, coverage of the soil or land incorporated in the system, and information, geostatistics information for population and housing. Cartography for participation. This system called SEAT is we have the insertion of observations to the people that register as participants and the registry of photos. And from this, these are general statistics on the databases, the flow lines, units of capture bodies of water, weather stations, hydrometric stations, recently included with information provided by the Meteorological Service, and CONAGUA, the units of vegetation, the geostatistics framework, and two statistics of the databases is 130.93 gigabytes. And this distribution, you can see what we have integrated. This is the Seattle. Here we can see some brief demonstrations. The videos take a while, but it's part of the applications. We have left a module outside for you to consult it, but you can see some effects in the process. This is at the level of simulation. And I will move ahead because I don't have too much time left. We also have the part corresponding to the visualization of the sub-basins, images, close-ups, where we can make the representations in 3 dimensions of what a cross-cut of the areas would be. And well, it can allow the person who is making the analysis of the region to have some kind of simulation of the area. We have an additional one right here where you can see also a close-up of a region, of a state, and based on the images of ortho photos to make close-ups of the area determining the population, the images that can be incorporated by the participants in order to have a greater volume of information. And another one that we can derive from the population census through generalized consultations. So here we see in a very simple way the mark of a sub-basin and then the statistical information, and with the tool shown quickly statistics having to do with population, housing, and other variables associated to the system itself.
Very well. The proposal we are currently bringing forth is a hydrographic information system for Mexico that exists in other countries. This would be a technical system for Mexico because we draw this from the INEGI. Now, based on this proposal, it would mean that we would need to convene the different institutions INEGI in the framework of the coordination of the systems, and to convene all the institutions to join efforts in the hydrological context and looking for the information that makes us struggle so much, and to integrate the information through different components. We're talking about space information of the real world, of the gathering of information towards the adequate models, and to have the function of the collaborators in the production of conceptual frameworks of standards. This is very important. This is a planning. It's not just join hands to work jointly. I will give you information and you give me information. But if we do it in a more orderly manner, we could come up with an information integration model, and then what will the purpose be for this information? Who will we share it with? And if we join efforts in the different government agencies, we can achieve more. Now, here in particular, what we need is a technological support of INEGI to implement a good system through application servers, to develop geomatic tools, and to incorporate this water flow model, maybe to compare it with mathematical models that have been mentioned, and to have the information of the stations, radars, and so on and so forth. So here the fortes is to join efforts from different institutions, and to have project inputs, and to reach the regional models, and to tap on this information in a very local manner. And of course, Mexico would have for the first time hydrographic and statistic information, water quality, rainfalls, and so on and so forth. And of course, the contributions to the different acts that have been enforced. Here are some of them. Some institutions. I would not like to forget any institutions. These have participated in the development of this system. Conclusions, well, for Mexico to have, like in other countries, in regard to water, and this is a national security strategic plan, and to have responses to the different questions through simulation. And another conclusion in the hydrographical network, the SIAT, are some of the foundations that could become a database on to a hydrographical information system for Mexico, with the participation of the government agencies in regard to the different space components, and also a consultation tool for the different units and society at large. So that would be my participation. Raul, if you have time, please look at the videos, the simulation of Seattle, and I think this would open up a view on the possibilities on the management of water in terms of concessions, in terms of the different implications and things such as flooding risks. And here you have much data that have been integrated, and I think it would be worthwhile to look at them. And well, because we don't have time, we cannot go through that, but you can look it up. Dr. Elena.